Chapter 13, Sample Problem Number 6. A mass hanging on a vertical spring is pulled down a distance d and released. The mass undergoes simple harmonic motion. 3 physics students make the following connections about this situation. Alexandra says, the maximum kinetic energy of this mass spring system is fixed by the properties of the system and does not depend on how far down the mass is pulled. How far the mass is pulled will only affect the frequency of the oscillations. Bruno says, no, that can't be right, since increasing the amplitude, or how far down it is pulled, increases the potential energy of the system. I don't think the amplitude has any effect on the frequency. And Chung says, I agree in part with both of you. I think the amplitude does affect the maximum kinetic energy, but I think it also affects the frequency of the oscillations. So we're going to take 2 tacks here. First, we're going to remember that the period of simple harmonic motion is 2 pi root m over k, and the frequency is 1 over the period. So whatever happens to the period happens inversely to the frequency. We can see that the amplitude does not play a role. No A here. So changing the amplitude does not change the frequency. So Alexandra is off on that, and so is Chung. So they're out of the running already. And then let's also analyze the energy situation. So we'll take between release and the first time it goes through the equilibrium position. The kinetic energy will be maximized when the spring is back at its equilibrium position. At the start, we would have 1/2 Ka squared, and here we'd have K max, and no potential energy. So we can see that, in fact, A definitely plays a role here, and so the amplitude definitely affects the potential energy of the system. So these are both correct. And therefore, this is not correct. If we look at this, the person we should go with is pretty clearly Bruno, who has both things correct.